In this video, I'll be reviewing the properties of logs. We will be going over the product property, the quotient property, the power property, and then 8 examples. So the product property is log of A plus log B is equivalent to log of A times B. The quotient property is log A minus log B equals log A divided by B. And the power property is log A to the B power is equivalent to B times log of A. What is important for the product and the quotient property is they must have the same base. So remember, since nothing is written, this is base 10. So since this one and this log both have a base 10, we can use the product property. Okay, so first example, we'll do log base 2 of x minus 4 equals 3. For this example, we will solve for x. So this isn't really using the properties of logs. This is using the rule of rewriting it as an exponential function. So if you remember, we can rewrite this as 2 cubed equals x minus 4. 2 cubed is 8, and then we'll just add 4 to both sides, so we know that 12 equals x. Alright, for our second example, we'll do log base 3 of x plus log base 3 of 4 equals 2. And again, we want to solve for x. So to solve for x, the first thing we need to do is use the product property. So since I'm adding 2 logs that have the same base, I can rewrite this as log base 3 of 4x equals 2. Now I can rewrite this in exponential form. So 3 squared equals 4x. 3 squared is the same as 9. And if we divide both sides by 4, we are left with 9/4 equals x. And we are done. Alright, let's do a third example. Log base 3 of 2 plus log base 3 of x plus 1 equals 4. So again, you are using the product property. If you'd like, you could pause the video and try to do this one on your own. You'll first want to combine these. So you have log base 3 of 2 times x plus 1, which is the same as 2x plus 2, And now we can rewrite this as an exponential. So 3 to the 4th equals 2x plus 2. 3 to the 4th power is 81. 81 minus 2 is 79. And then we will divide by 2. So our final answer is 79 halves. So let's try doing an example where we're solving but using the quotient property. So example 4. Log base 4 of x minus log base 4 of x minus 6 equals 2. So because we're subtracting our logs, we can rewrite them as log base 4 of x divided by x minus 6 equals 2. Remember, the first log is what's going to go into the numerator. So now we can rewrite this in exponential form, so I can solve for x. So 4 squared equals x divided by x minus 6. 4 squared is 16. At the same time, I'm going to multiply both sides by the denominator. So I'm going to have 16 times x minus 6 equals x. I want to distribute, so 16x minus 96 equals x. Now I want to get both of my x's on the same side. So I'm going to subtract x to get 15x. And at the same time, I'm going to add 96. And finally, we'll divide by 15. And 96 divided by 15 can be simplified to 32 fifths. All right, so example 5. In this example, we will evaluate log base 2 of 32 cubed equaling x. So for these problems, you have to be careful. You might think to rewrite it as 3 log base 2 of 32, but we should try rewriting it in exponential form and seeing if we can find a common base. So we can rewrite this as 2 to the power of x equals 32 cubed. Then we should ask ourselves, is there any way I can rewrite 32 as a base of 2? Hopefully you are thinking yes. 32 is the same as 2 to the 5th power. So I'm going to replace 32 with 2 to the 5th. So now, since I have a common base, here let's simplify. Can we write this as 2 to the 15th? So since I have a common base of 2 and 2, we can go ahead and set the exponents equal to each other. So we know that x equals 15. All right, another example just to make sure we feel comfortable with this. Example 6. Let's do the same thing, but with log base 5 of 125 to the 6th power. So, first rewrite this in exponential form. 5 to the power of x equals 125 to the power of 6. Can we rewrite 125 as base 5? We sure can. So we can rewrite it as 5 to the 3rd power. So then x is going to equal 3 times 6, which is 18. Alright, so Sometimes you can't get a common base. For example, 7. Solve for x. And let's leave our answer in terms of logs. Or what we can say is just find the exact answer. Oops. So if I have 1/3 15 to the x power equals 6. So first of all, we want to multiply both sides by 3. So we're going to have 15 to the power of x equals 18. Now you should always try to get a common base. So can we rewrite 18 or 15 so they have the same base? No. So we want to rewrite this as a log. So this will be log base 15 of 18 equals x. Now we're not in base 10, so we can rewrite it as if we were going to base 10. That will be log of 18 divided by log of 15 equals x. And we're done because I asked for the exact answer. If we wanted to, we could use our calculators in base 10 to solve. Final example 8. Let's solve for x and find the exact answer. So let's do 3 times 8 to the power of x minus 4 equals 5. So first things first, we need to divide both sides by 3. So we have 8 to the x minus 4 equals 5/3. We should now rewrite this in logarithmic form. So log base 8 of 5/3 equals x minus 4. Now we can add 4 to both sides. Actually, I'd be careful about that. So you can add 4 to both sides, but remember that it's not a part of the logarithm. Let's just do it. So log base 8 of 5/3 plus 4 equals x. Now you have to be careful because this and this are different. Now, because we aren't taking the log of 4, we can't combine these. So all we're going to do is rewrite our logarithm in base 10. So log of 5/3 divided by log of 8 plus 4 equals x. Another way to write this, because we have a fraction, is log of 5 minus log of 3 over log 8 plus 4 equals x. So since we have a fraction and a fraction, we can expand our numerator so it doesn't look as weird. And we are done. I hope you found this video helpful.